Hello, welcome back to Cracking the Cryptic, and a fascinating looking puzzle. Long time since I've done a galaxy puzzle, it feels, and this is a debut by Yan Gang, who has created this galaxy puzzle. I'm looking forward to giving it a go. The rules, well, we'll be careful going through the rules because I think they're going to matter, and I want to get it right, frankly. So we will be careful about that now. Let's first of all have a little think about what you can do to engage with the channel. You can go onto our Patreon, and there you can see extra videos. You can get extra puzzles. We've had various free puzzle packs and some others for patrons who are paying patrons, and they include Rockrat Zero's 600k Bang and a number of other things. There's also, of course, the monthly rewards. August's being Skajojo Bo's CTC clone pack, and these are just brilliant collections of puzzles. We urge you to give them a try. That is on Patreon. We've also, of course, got all of our apps which you can try, individual puzzles by some of the world's best, and check them all out. There's no Galaxy app, I can tell you, but there are lots of other alternatives. And we've also got our merchandise and Sven Sudoku pad, all on the links under the video. Please, please, please check them out because they are great fun, great ways to engage with us. There's also links to the Discord server where a lot of people congregate, and the catalogue of our puzzles, how to contact us, all sorts of things. Yan Gang contacted us with this puzzle, and I am going to go through the rules now. It could be Yang Ang, I don't know. Anyway, normal Sudoku rules apply. We're going to try and put 1 to 9 in every row, column, and 3 by 3 box. We then have to divide, well, no, not then, but probably before that. We have to divide the grid into non-overlapping groups of orthogonally connected cells called galaxies. Each galaxy is 180-degree rotationally symmetric around its center. I will show you some examples in a moment. Orthogonally adjacent galaxies cannot be congruent, which means they cannot have the same shape and size, even if they're rotated or reflected. So this is a possible galaxy shape. It's got a circle in the center. We'll come to that rule in a moment. It's 180-degree rotationally symmetric. But if that was a galaxy, this couldn't be one there in that shape, because it would be congruent. It would have the same shape. Understand? Okay, well, I think I do. Now, each circle, as I was sort of hinting, is the center of a galaxy. Not all galaxy centers are necessarily given, but every circle that is given is the center of a galaxy. The number in a circle indicates the sum of the digits in that galaxy. When a circle appears in the center of a cell, the corresponding number is given in the top left. When a circle appears in the center of a cell. Well, okay, so sometimes the number is written in the circle and sometimes it's written beside the circle. And this is so that the number can still be seen after placing digits. Okay. Digits may repeat within a galaxy. Now that is partly going to explain how we can have a 96 in the puzzle. Anyway. Do give it a try. Those are the rules. That's all there are. It's relatively simple as a concept. Once you've grasped this idea of a galaxy and its rotational symmetry, you can have very small galaxies. They could be no bigger than 1 cell, I suppose, or a 1 by 2 domino would be a galaxy. Who knows? But we will see. We will see how it goes in this puzzle. I'm going to restart my clock. No idea how difficult this is meant to be, but no galaxy puzzle is absolutely straightforward. Let's get cracking. So, where can we possibly start? Well, I was going to look at this 9, which could be a single cell. If it extends out of, I don't know why one is drawn to the central cell in the grid somehow, because it's no different from any other galaxy. But if it extends outside this single cell, then it must have another cell to make it symmetrical. So this 9 is either those 3 or that one. Useless. This 14 is much better. Right. This is on the edge of the grid. and it's the center of its galaxy. Now that means that no cell outside row 1 can be in this galaxy, because it couldn't be reflected. It would reflect outside the grid. Therefore, this galaxy is confined to row 1, and it is either 1 cell big, which it's not, because you can't have 14 in a cell, or 3 cells big, which it definitely is, or 5 cells big, or in fact that's bounded by the grids. That's as big as it could go. It can't be 5 cells big, because the minimum you could put in those 5 cells is 1 plus 2 plus 3 plus 4 plus 5, which would equal 15. So that one's definitely 14. Let's give us a pen tool and start bounding our galaxies. Now let's use the perimeter thing again here. Again, this galaxy center is on the perimeter, so we can't go into column 8, 7, 6 or any other column apart from column 9, because we couldn't reflect. Now this time we're going to have at least, remember, we're either doing 1 cell, 3 cells, 5 cells, 7 cells. We're symmetric. 7 cells, the maximum, yeah, okay, it could be 7. It's 5 or 7. I can draw a line there, I guess. It can't be 7. That's totally obvious, because this cell is clearly in the 19 galaxy. So we can bound this 30 galaxy there and there at the top and bottom. And we can color it, let's say, orange. And then we move to this 15, which is at least 3 cells, because it can't be 1. It could this time be 5 if they were 1, 2, 3, 4, 5. So that one is an unbounded galaxy for me at the moment. Right, now this 19 galaxy is basically on the perimeter. Those 2 cells are in it because they're touching that 19. Those 2 cells are in it, clearly. These 4 cells could add up to 19. Now, I think now the only other cell we could add in on both sides, obviously not to the right, therefore not to the left, above there and below there, we could take these 6 cells. And since we're allowed repeats, that might be the shape of the 19. So I'm going to color those cells and try and bear in mind that these ones might be yellow. I mean, I suppose I could do that. Now, this 27 is a bit bounded by the 19 cage. In fact, I can draw some boundaries like that. And the 27 cage is clearly bounded on the left side. I should have chosen a different color, shouldn't I? Let's do all my boundaries in... Oh, be careful, Mark, in black. That is the boundary I have established. Sorry, I'm just redoing my boundaries in a black color. And the only danger with using black is it might interfere with my perception of boxes at some point. That was why I was avoiding it before. Anyway, this is correct so far. Now, this 27 cage cannot stop there. Let's color the 15 green again. And the 27 cage has to extend because we have to get up to a total of 27. So far, we could only put a 9 and an 8 in it at the maximum. Where can we possibly extend? We can't extend to there because that would have a symmetrical opposite of here. So we must extend to these 2 cells. And after that, it's only those 2 that are possible. I can do some boundaries here, therefore, but not many. Well, more than maybe I thought. So we've bounded in this 27. It's either 4 cells or 6 cells. The 15 is now bounded at both ends. I hadn't noticed that happening. And we can colour that in. So that is 15 in 3 cells there. This 21 cage... galaxy, not really cage. Oh. Okay, those cells are in the 21 cage. Now, I wasn't going to make any statements about whether they extended further or not, because I think they can. However, this has quite serious ramifications for the 96 cage, I've just noticed. 96 obviously a massive number in this context. This galaxy has to extend out somewhere. And it clearly can't extend to either of those cells because they're in different galaxies. So I'm going to make this a new color, purple. Where is purple going to extend? Well, it can extend up and down, but only that far. It could extend to that cell, and that is worth bearing in mind. That rather depends on at least the 27 cage. But other than that, and I mean, how much is our maximum total? Oh, it could go here and here. And then I think we're done to the northwest and the southeast. What I'm trying to say is, these are all a possible area for the purple to extend in, but you can't, you now would have to extend in row 6. Even this may not be enough. Anyway, what is the maximum total we could have got to now? It's 98765 in column 4, that's 35, and let's imagine a 98 and a 98 in the other places. That would take us up to something like 69. And we're still 27 short of our total, so we must extend in row 6. And we must extend by far enough to give us at least 27 more. So I'm definitely going to paint those purple. Now, the maximum we can extend in row 6 is there. But then we could extend to these cells, or both or all. Now, this wouldn't be enough on its own. Let's add up the maximum again. Let's say this is 42 in row 6, plus 17 in row 5 and 17 in row 7. And that's 76. That's not enough on its own, so we must extend north and south, at least to those cells. And this is quite important, just on its own, because that has jammed in this 9. This now can't extend to there or there, so it's not allowed to extend to there or there, so it's a single cell, and there is our first digit in the grid, in that lone galaxy in the center of our universe. That is a 9. I was thinking, ooh, that's really going to help. Yes, it is. Look at this digit, this 21. Oh, bother. Well, no, not bother. This is okay. I can do something with this, which is not extend up to here, because that is now purple. So for this to extend out of its own cell, which it has to, it's going to have to go left. Now, it might then pick up those digits and be that shape, although I think that's going to be very hamstringing of purple, but it definitely has at least those. Now that is enough to fulfill yellow if it was an 876, adding up to 21. However, what it has done is meant that purple is constrained, it's not that's meant purple can't go there. It's meant purple can't go here. So now, what is the maximum purplage? I think extending left and right, you could reach all of those cells, which would add up to a minimum of 42 plus 8 plus 9 is 59. Then if you had a 9 and an 8 here, or an 8 and a 9 in that order, what were we on? 59. Plus 8 and 9 is 68, 76. We still need another 20. That's more than 2 cells. We're not allowed to go there. We're going to have to go up to here and here. And we're going to have to turn here and here. And I think we're now going to have to get all of these in. So again, let's do the maximum. Those are definitely in. So what is the maximum of this group? 42 here. And 30 here is another 9876 there is 72, plus an 8 here is 80, plus say a 9 there is 89. We still need to extend. The only place we can extend on both ends now is those places. And that is the shape of the 96. I think it's got to be. Right. Interesting. Oops. Now, this 21 must be fully bound in now. It can't extend up or to the left or right of row 7, so it's completed as a 21 like that. How? Oh, these have all got to obey galaxy rules. We aren't given the centers. Now, remember that rule about no congruent shapes, which I haven't thought about until now, but it is worth thinking about. Oh, first of all, this 21 has got bounded in, and we can seal that off. That is an 876 triple. Now, down here, what I'm thinking is that we could have made this. We can't make it 4 single cells because of the congruent shape rule. Single cells can't be next to single cells. We can't make it 3 and 1 because that 3 would touch that 3, and that's not allowed. So, and we can't make it 2 and 2 because they'd be touching each other. So I think the only way to do this is to have 2 separate 1s and a 2 in the middle. And I mean, maybe it doesn't matter how we colour these galaxies that we're not really focusing on. Now this digit has got shut in. It can't be blue, purple or yellow. I'm going to make that orange as well. Don't know when orange became my go-to colour for a 1-cell galaxy. It's obviously not here. Now, does that mean these yellows have to be yellow? I don't like this colouring I've done. I'm getting rid of that. It's putting me off. Right. Now, we're very unlikely to have to rule out a shape of this style from touching itself. This 20 shape can't go north. So when that extends, it extends left and right. Okay, with this shape, this is interesting, this cell rather. That 20 is bounded on the left because of the boundary wall on the right and symmetry. Now this cell, what is this in? It's not in purple, it's not in light blue, it's not in dark blue. It can't be a single 1-cell region because it would be touching another one. So it must go north, and therefore this 21 shape includes those 4 cells at least. Could include a couple more, probably not more than that. And we've got this 23 shape starting to form. That definitely needs more. Goodness me, this is interesting. Right. What do I do next? Because this 20 shape, this is blue, dark blue. It can't be a single one, again, for the same reason. It's clearly not purple or light blue. So it is dark blue. That's dark blue. Now, can we rule that, well, we can block in some lines there, but these two could be in dark blue as well. And yeah, it's easily done. 1, 2, 3 there, 1, 2, 3 there is 12. And anything up to an 8 there to get to 20. Okay, so I don't know. No, I was just looking at this 2-cell area and going, it can't be 2 1s. That's not relevant. Okay, this 21 shape? Don't know. Oh, don't say I'm going to run out of galaxy work and have to do numbers. I don't want to do that. Really? I can't believe that this 27 isn't finished. That's a little annoying, but that could be a 1. This could be a 2 or a 1. This, remember, can be that shape. This could be a 1 or part of an H. This could be an X or like that, or any kind of straight thing. Even that's possible. What about isolated corners? This one. Well, this can't be in any of the galaxies I have found. I have started colouring because it just wouldn't have an opposite cell. Same is true for this cell. Actually, the same is true for this cell. So all of these three are in new galaxies that have not been described. But, I mean, it could be a 1 and a 2 in either direction. I don't know. This 23 seems to max out at that shape, and that must be possible. God, okay, I don't know where we are. Right, I'm going to think about how to form the 96 total. Because I can't see any other total that's really helpful. And I'm not sure this is really helpful, but it's all I can think about doing. So, maximum here is 9876543. Now that is 42, which is 45 minus 1 and 2. The maximum here is now a 5-4 pair. 4651 we're up to. Then you could have an 8 here and a 9 here, which is annoying. 68. Those three together could be 987, which is 24 more. Oh, we're up to 91. We haven't actually gone past 96 yet. This one is at least 5. And that is a kind of degree of freedom marker, isn't it? Don't we only have 4 degrees of freedom over those maximum groups that I just nominated there? And there may be different ways of looking at this. Like, we might look at those cells and go, the maximum they can be is 9543. I'm going to try this, by the way. 9543 is 21. These could be 87654, which is 30. That's 51 between those highlighted cells. Then a 5 and a 9 here, maybe? What are we up to? 51, 65. A 9 here is 74. And then again 987 here is 98. Now, have I really reduced the degrees of freedom that much? Let me try that again. So I'm saying 9543 in box 4 is 21. 87654 here is 30. That's correct. So 51 so far. Then I'm saying a 9 and a 5, 65, a 9 there, 74, and then 987 down in box 8 gets us to 98, and that way there's only 2 degrees of freedom. So this group is 987 but with 2 degrees of freedom, so maybe 985. Now, how else was I doing it? This was 9543, but there were degrees of freedom. We must use the 9, clearly, somewhere there. That's not a very interesting finding. This one was 87654, but with 2 degrees of freedom. And this was 5, but with 2 degrees of freedom. This was 9 with 2 degrees of freedom. We are getting in a bit of a sweat here. This was 9543. Oh, and look, there's going to be some implication on the orange, because in this row, oh, if these are maxing out. Oh, what's happening here? Okay. I like the way I've divided it up this time into getting 2 degrees of freedom. I'm just going to try and stick with this. This had to be 87654. There are 2 degrees of freedom. So we're not using 1, which is in one of these cells. Not very interesting, that. We are definitely using 8 and 7. And we might definitely be using 6. And I think that we are. And this was 9543. That was 9 with 2 degrees of freedom, makes it 9, 8, or 7. That can't be a 9 by Sudoku. That's probably not the way to look at this. Okay, let's think about this orange. Let's try and reconstruct it row by row then. So I'm going to imagine this was 987 up here, the max. So these have to be at least 6. And this is maximum 42. Is that the right way to look at it? No, it's not. Okay, let's look at, so let's add the 6. No, let's take that as maximum 17. This is minimum 13. So that plus the purple area is 109 minimum. Now how are we making up that in purple and orange there? 109. So now we're looking at those 8, maximum 44. These 3, which can't be 9876, this is the interesting part, maximum 12. So we're up to 56. These 3, I suppose I have to say maximum 987. Just about. I'd know exactly where the digits would go if this was right. I can't remember what I got up to. 44, 56, and I'm aiming for 109, and that was maximum 24, annoyingly. So we're up to 80. These two, maximum 17 is 90. Well, no, let's start with that. We're up to 104, but that is 113. Okay, that's more degrees of freedom, so that didn't actually help. Oh, this is so confusing me now. Sorry, I need to just try and figure out what the best way of dividing up this purple area is. Or, if this is 987, which I've been talking about for a while as a possibility, this green would have to be 654. Then 1, 2 and 3 would go in these cells, and blue would have to use all 3 cells. You couldn't just do blue with 5 there and 22 there. In fact, this is quite interesting here. Okay, but if this isn't 987, this could be as adding up to as little as 22. That's still not, it's still, yeah, okay, great. Minimum 22. Plus 15 is 37. Maximum for these 3 cells is 8. I am liberally using 45 as the secret, the total of every box in this Sudoku and every row. Anyway, maximum for these 3 cells is 8. That means the maximum for 2 of them is 7, and this, and that is the absolute max, is 7. These 2 would have to add up to 20 if we weren't to extend blue. So we are extending blue. That 27 goes to here. Okay, well that's a finding. Now, does it mean... And these add up to either 6, 7 or 8. So these add up to 19, 20 or 21, which are quite big numbers. And they mean the... Plus this 90, oh, but that might be a 19 including those. Is that possible? Yeah, I don't know. I don't know if that helps. 1 has to be in this group of blue cells. Now, if 2 was here, these could be 2, 6, 7, leaving those to be 5, 8, 9. This would be 1, 3, 4. That all works. If this was, if there was a 3 here, yeah, I don't know. We're close now. I feel like this is going to be 24, but I don't know how I know. Oh, the congruent rule. I haven't thought about that for a while. Is that any help? No, I don't think it is, annoyingly. No, I can't see how that's relevant anywhere I'm looking at the moment. Come on, let's try and get some more fixation on the purple numbers. These are obviously from 1, 2, 3, 4, 5, and that is a bit limiting in this 30-some, especially, and I've got to think about these again combined with those. Okay, just those two this time. So if that's 9, 8, 7, these add up to at least 6, plus the 96 in purple is 102 in those two cells and all the purple. Now, how am I getting to 102? 44 max, 12 max is 56. Then just these two, a 9 and an 8, say. I don't know if they are the max, but we were up to 50, what were we up to? 44 and 12 is, we were up to 56. We're aiming at 102. 9 and 8 there, I have to allow 73. 24 here is 97, and 5 here is all I'd need to get to 102. That does not butter my parsnips. Man, this is very tough. Is there some easier step? There might be. So do I need... Oh. Can these contain a 1? 9541 would have used up all the degrees of freedom in the division by boxes that I was doing, which was the most helpful division. Okay, let's imagine this was 9541. What I'm trying to do is imagine 1 is in one of these cells. You'll see why, I hope, in a minute, if I can make it not in one of those cells. If 1 is in one of these cells, the maximum for these is 19. These can be 8, 7, 6, 5, 4 is 30, takes us to 49. This can be 14, takes us to 63. I'm just looking at purple now. 9 there is 72, and 9, 8, 7 here is 96. Now, is there one reason why that won't work? I've put 1 in this group of cells with 2 out of 4, 5, 9. But that's a 9 in this theory. So this has to be 1, 4, 5. That's a 9. This is 5. This was going to be 8, 7, 6, 5, 4. The 5, 4 would have to be here. This would be 8, 7, 6. That would leave these to be 2 and 3. That would be 5 and that would be 4. These would also be from 1, 2, 3. These would be 1, 2, 3. Wow, okay, it doesn't work because of the 30 cage. That would be 1, 2 or 3, and that would be 2 or 3, and the max they can add up to is 5, and those would have to add up to 25 or more, and they can't do that in 3 cells. So that is a very, very complex way, but it's all I can manage of seeing why it will not work for 1 to be in one of those cells, or in any one of these 4 cells. So 1 is in one of those 2 cells, and that the whole reason I did that was to place 1 in box 5, and I thought that might help. Now, this is now 2, 3, 4 or 5. Now I'm going to say none of these are 1, none of those are 1. That's not a 1 because of the, well, just because of Sudoku. We've got a 1 there and a 1 there. There's a 1 in one of these cells. I don't, well, if it was there, this is a 5, and that's 9, 8, 7. Now that's possible, but if that's a 5, these can't be as, these can only be 4 and 3 at a max, and that I think takes out too many degrees of freedom. We could still have 42 here. 8, 7, 6, 9, 5, 4, 3. Yes. 3 and 4 there is 49. 8 and 9 there. I have to allow 66. 9 there. 75. And 24 here. Oh my goodness, it gets to 99. How did that happen? That's because I'm not doing the optimal box-based maximization technique. That's why it happened. Oh gosh, okay. So let's think about this again. 9543 maximum here is, I'm just going through the same ground because I need to, 21, and a 9 there is 30. 87654 takes us up to 60. 5 and 9 takes us up to 74, and 987 here takes us up to 98. Now, where am I losing 2 degrees of freedom? I'm using 2 degrees. I've got 2 degrees of freedom. Where do I lose some of them? And is it here and here? So what I'm basing this on is a 5 there, 87654 here. So that would be a 4. We'd have 5 there, 4 there. These would be 8765 playing next to a 9 there, which would put a 9 here, because there has to be a 9 in this group. So that would be 543. That would be 876. This again would be 54. And that doesn't stop this being 987. Don't lose the degree of freedom. That's so irritating. But it's based on 8, 4, 5, 6, 7, 8, 5 and 9. So if I was to lose 5, I've got 4 and 5 there in this maximization. If I was to lose 1, if I was to lose the 5 out of there, this would be 4 and 3. That would take away both degrees of freedom. So we'd still have to have 9s everywhere we possibly could in all of those cells. We'd have to be using 8765 in the central box. And 543 here. Oh, goodness gracious. I mean, everything seems to come down to using 987 here in box 8 in purple. Oh, can I use this 27? Maybe I just add up 15, 27 is 42. Let's assume the 19 was confined to just that yellow area. It's 61. If this is 24, we're up to 85. Those two in that situation would be no more than 5, which is quite minimal but not failing. This column, 30 there. If that group of cells adds up to 49, then that pair minus 4 equals this pair. That's fine. Ah, so close to being able to break through and so unable to do it. Do I really need to? I'm trying to look at these other circles now. Have I not done enough there? This 23 pair either extends there, and then it could extend here as well, or it extends to those cells. Now, if this had to extend east-west, it would have to be either there and there, or there and there, or maybe both, or extending further, and that's confusing. What I'm wondering is, if I draw a yellow shape of exactly that style, then I can't draw a blue shape of exactly this style here, but I don't see how that's helping me, certainly not at the moment. I can't fill the 14 cage, or the 20, or the 21, or the 15. I don't see how I can. So this 27, this is my lifeline now. And these three add up to 6, 7, or 8. I've said this before. These add up to 19, 20, or 21. That doesn't require them to have a 9 or anything like it. Oh, I don't know what it means. This is so annoying now. Now, these add up to 24, 23 or 22. They definitely have a 9 in. I've only just seen that. That's so pathetic, but they do. And therefore there's a 9 in one of those cells. I mean, that's so uninteresting, it's mind-blowing, but still. These could be 8 plus a pair adding to 7. Interestingly, if that was 985, these would have to add to 8 without a 5. They would definitely be 1, 3, 4, and this would be 2, 6, 7. If this was 9, 6, 7, there'd be an 8 in here, but along with either 5, 2 or 4, 3. I can't work with that. That's not enough. Oh my goodness, I just need to eliminate 1 degree of freedom somewhere. I feel like, what happens if these aren't all 9s? If I lose a degree of freedom off one of those, that's interesting. If that is a 9, that has to be 9, because this purple group in box 4 needs a 9 and it would have to go there. We know there's a 9 in one of these two. Then only this one doesn't have to be a 9 out of the group. If that's a 9, well, we definitely need a 9 in the group in here. So either of those being a 9 makes the other one a 9. So the only way for either of them to not be 9s is if they were both 8s, which is taking away the degree of freedom and utterly impossible, because this can't be an... Oh, this has... Oh, hang on. Does this have to be a 9? For this not to be a 9, there's a 9 here. And then this isn't a 9, and this has become a 5. Oh, but yes, okay, which is possible, because then we can have 9, 5, 4, 3 here. But we've lost 1 degree of freedom there then. If this is not a 9, we've lost a degree of freedom here. Now this is quite big, this is quite big. If that's not a 9, then there's a 9 here and that's not a 9, and we've lost 1 degree of freedom. Because those were extra on the version where I add up the boxes. Okay. So for this not to be a 9, we're down to 97. Maximum score, with say 8 and 5 there, 4 here. That would have to be an 8 now. 8, 4, 5, 6, 7, 8. That could be 9, 4, 3. 8, 5. That would have to be 8. This would be 9, 7 or 9, 6. Ow! Why isn't it enough information? Oh, look. That 1, good grief. It's just Sudoku. It's looking at this other blue area, putting a 1 in there. And then one of these is 1. I'm sure that's not thrilling, but it's true. This pair adds to 5, 6 or 7. I know that. That 1 I've put in there, does there have to be a 1 in the 19 cage? No. This 15 cage doesn't have a 1 in. It's either 2, 6, 7 or 2, 5, 8. Or it's got 3, well it could be 4, 5, 6, which is what I think it's going to be. Or it's got a 3 in it, and either 8, 4 or 5, 7. Oh man, I don't know. This is not a 1 now. But these two had to add up to, I think it was a maximum of 7. Oh no, it depends on the shape of the yellow cage. I don't know that. 8, 7, 6. Oh, this is so annoying. For that not to be a 9, we've lost a degree of freedom here, because this can't be a 9 then. Having repeating numbers in cages is very confusing. That's just a statement of principle. I really want, 40 minutes in, I really want to make some progress. I just don't know how at this point. I mean, we're right on the edge of making progress here. And maybe I've got to keep thinking about this orange cage. Maybe I just add the whole orange cage. Maybe I do. And the whole of purple. And then see if I'm coming to a total that I can use. So, box by box, 9543. I hadn't thought of this. I mean, it's probably the simplest thing to do. 9543 is 21. 87654, that's 30. We're up to 51. Well, those. It can't be 98765, because those could be 54. Wow, and that, but that was 5 or 4 in the maximum here. So let's say 5 and 3 maximum here. Is 8 plus 22 in those cells, 987, is 30 in this box, to go with 30 here and 21 here. That's 81. But that's used 2 out of 987 there. So let's say that was 7, 8. We have 9, 6 here as a maximum. (81) 15 is 96. 120 and 9. 129 for total of 126. 3 degrees of freedom. That's even more just than I was working on before. So that did not add to my numbers. Or did it? Because if I'm assuming 9543 in those cells, but 789 in these ones, well, that has to be a 1. Oh, how can this be high? Haven't I worked out this can't be? No, I haven't. I've worked out that if those are high, these are low. These add up to at least 6. That's what I worked out before. So I haven't even ruled out this being a 1, which is frankly quite frustrating. I cannot get my grip on this. I mean, I'm morally sure that these are all 9s. That's not good enough. I know it's not good enough, but what is it that is going to stop me making that assumption work? Because I can't see it. If that's not enough, for that to be a 9, that has to be a 9, and for that to be a 9, that has to be a 9. These things I know. So for them not to be 9s, that's not a 9, and this is one of the 5, 4, or 3 that could go in this box. Maybe it's all around here, where I'm saying 87654, but I've also got big numbers down here. So 2 in this column, probably at the top, but I don't have any constraints up there, do I? This 21 cage isn't giving me constraints. I don't think it is. Have I forgotten something about the congruent rule here, or the 21 cage? I don't know. Okay, well, it can't be that shape, because then it would be touching this and it would confine it to that. So it's not that shape. Oh, it could still be that shape, weirdly. Don't see why not. If 21 yellow was 4 straight cells, then 23 blue couldn't be 4 straight cells. That doesn't look likely to help. It's about the numbers. I don't know how to get the numbers into this puzzle. This is my problem. This is my problem. Can I rule out the big old H here? I don't think I can yet. No, I've got nothing for that. This 30 and 4 cells I know all about. 30 and 5 cells, not so much. Okay, for 9 to be in this group, which keeps 9 out of there. Oh, then we get 9 in one of these 3 cells. I don't see why it's a problem. Oh, 9 in one of those 2 would make this a 1, 2, 3, 4, 9 cage exactly. It's interesting. Nine there, I don't know, that seems very plausible. I mean, I don't think it is a 9, but it seems like it could be. It's something to do with this group of cells. I'm not somehow calculating. Right. It's not about those, is it? In these 2 boxes clearly add up to 90. That is the rule. If I'm saying that that has to add up to, well, it's either 30 or within 2 of it. So 28 to 30. Well, in fact, the maximum there is 30. The maximum here is 21. That's 51. And there are 2 degrees of freedom from the purple. So that's 49. Then we add these digits in. 49 to 51 in purple. We add these digits in, which are 31. And we're up to 80 to 82. And there it is. There it is. They have to be 80 amongst there, so that these 4 cells can add up to at least 10, their minimum. These are 1, 2, 3, 4. Wow. Okay, those aren't 1s. There is a 1 here, we know that. These are a group of 1, 2, 3, 4. And now I know that these definitely add up to, let me do the maths again, 31 and 10 is 41. These definitely add up to 59, 49, 49. And that's the 2 degrees of freedom from purple. Yes! Yes! If they add up to 49, I can max this out at 14, that at 24, 38, that at 9 is 47 to get to my 96. There we go. So, incredibly, what I should have been adding to purple was those 4 cells. I didn't spot that. I've spotted it now, so I did spot it, but it took me a long time. So I put in 5, 9. This is now a 9, 8, 7 group. This is a definite 9. I worked out earlier that once that was 9, it's Sudoku that puts a 9 there. And we're getting some 9s. That's a 9, and this isn't. There we go. There's a start. Now, this is 987. This 15 cage is 654. This is 1, 2, 3. And this 27 cage now adds up, well, these blue cells add up to 21. They don't have a 5 in. You can see that. But they could be 6, 7, 8 with the 6 here and 7, 8 here. Or they've got a 9 in which case the 9 is here, and then these have to add up to 12 without being 5, 7 or 9, 3. They would be 8, 4 with an 8 there and a 4 here. So we are quite limited there. And these add up to 21. If that 19 is confined here, that's 40. And these two add up to 5. Or what happens if that's the 19 cage? Then this whole area adds up to 40, and that has to be 5 more than that. Oh, bother, that's possible too. Okay, never mind about that. Let's do... Come on. 1, 2, 3, 4, 9. These cells are from... They are 5, 6, 7, and 8. These can't have a 5 in anymore. They're 2, 3, 4. Ah. Now, that's a 2, 3, 4 squad. These are from 5, 6, 7, 8. These include, well, these are from 1, 2, 3, 4, 5. They have to include a 5 in this box. So there's no 5 there. That's a 6, 7, 8 triple. This is a 5. This is just Sudoku, and I'm just not spotting it all. Yes, now it's more easily done if I'd worked out that 5 there made that a 6, 7, 8 triple. We're getting there. We're getting there a bit more slowly than usual, but we're getting there. So there's a 1 in one of these. That's a 5. Come on, come on. There's a 5. There is a 1 there, so there's no 1 in this group of cells. Now, what about this cage now? Because these can't add up to more than 7 between them. So these have to add up to 23 or 24. They are either 986 or 987. And they definitely have a 9 and an 8 between them. And these must have a 4. They're either 4-3 or 4-2. So these don't have a 4. Wow, I mean, this puzzle is mad, but I feel like I am committed to it now. Now we've got, there is definitely a 9 in one of those cells, so this isn't 9, so this is 9 in the bottom row. These two now definitely add up to 12, and they are 4, 8. Now, in the bottom row, I've got 1, 2, 3, 7 to place. Do I know anything about those digits? I don't think I do. However, I've got 21 in this box, and that 9 is 30. These add up to 15. So that can't be 1, 2, 3, or that would be another 9. So 7 is definitely over there in the group that adds up to 15, along with 1, 2, 5 or 1, 3, 4. But there's no 4s in this group because 4 by Sudoku is in that box. So this is 7, 1, 2, 5. The 5 goes there. This is a 1, 2, 7 triple. Getting excited. We get a 3 in the corner. That's 3 in the corner. This pair now is a 4, 2 pair. Because that was it was either 4, 2 or 4, 3. 3 in the corner sorts that out. So this is 9, 8, 7. That 4, 2 pair makes this 3 and this 1. Makes that not 3. And the 3 that now is in one of those cells make those not 3. Right, now this 19 cage, if those are in it, these add up to 15. And then by maths in this cage, this is going to be 45 minus 15 is 30 minus 12, 21, 24. That would be a 6. If they're not in the cage, 19 and 21 is 40. That's a 2. Oh no, both of those are possible. Okay, this can't be 8 by Sudoku. Let's do a bit of Sudoku on this puzzle. That's not a 5. Got that 2, 3 pair there. Oh, I don't know. This is 4, 3, 6, 8, isn't it? When the 4 is not in the bottom row. So there's a 5 over here. Oh, that was 78924. That's 3. 1, 5, 6 remaining in this column. So weird. I don't know what this galaxy is yet. 1 in this row is fixed here. It's not doing anything for this 2 or 6. 4, 8, 9, 3, 1. We've got 2, 7, 5, 6, 3. No, 2, 3. Oh, that's a 2, 3 pair looking at that cell. That's a 4. And that is giving me a 1, 2 pair over here. And that's a 3. Let's get rid of the corner mark. I mean, uniqueness tells me that's not a 1, 2 pair, but I'm not using that technique. This is a 2 by Sudoku in the box. 4 and 2 are resolved there. This is a 3, 4, 5 triple, and that one's not 5. Okay, more progress. Now, this 20 cage, minimum here is 5, plus 6 and 7 is 18. Well, that's what it's got to be. This is a 2, and that's a 6, 7 pair, and we get 8 in the center of the 30 galaxy. That's a 7, 9 there. 2 now by Sudoku has ended up here in box 9, and therefore this yellow cage is suddenly bounded above and below as 19. Isn't that intriguing? So that one goes orange. This group goes together because we have bounded the blue 20 cage. That goes together. Let's make it green. Okay, so doesn't really matter in a way. Oh, we can do this digit because we can add the box. That, oh, we've done it. I had 3 in the corner. I thought I'd written that in a while ago. I get another party. Don't deserve the second party. 3. Those are from 4, 6, 8. Right. 5 is definitely in one of. Oh, well, this is 1, 5, 6, 7. Ah, well, okay. I don't know the order, but it gives me a 5, 6, 7 quad, triple in the column. That's a 4, 8 pair. These include 1 and 3 and either 6 or 7. Now, are they in the 21 cage? Now, remember, this 21 cage can't do that. Ah, and it's oh, I don't know. It could be 8, 7, 6 across there. Oh, goodness. I think this puzzle still has some holdout left in it. I said at the beginning I didn't know how long it would take. I didn't realise it would take this long. There's my answer. It's not really an answer, is it? Now, come on. 2, 4, 5. 2 is in this group. 5. It can't be 3, 2, 9, 7. So this yellow cage does extend left and right. And that means either there and there or there and there. Now, it could go further. Perhaps. No, it can't take them both because then that group of cells would add up to 18, which is not enough. Oh, as it is, one of these groups adds up to 18. And we can't really go beyond that. Even, oh, well, this is the sort of thing I was pondering. Could it extend that far? 15 in the top cage is 18. Then a 1 here and a 2 here. I suppose it could. That's so annoying. But I do want to think about what is in it. Oh, that's not a 4. I haven't even seen that. $14 cage. Oh my goodness, still got work to do. Basically done all of these cages in the bottom half. We know what the contents are. How does that not entitle me to make dramatic forward progress? Honestly, that's not a 5. That much I know. So that's a 6, 7 pair. So that is a 5. Okay, well that gives me the number in the corner. But I don't think this number in the corner can be in a galaxy with a marked circle. I'm certain it can't. So it doesn't help. Well, I suppose it rules out 5 from this 14 cage. It doesn't help yet. It might help. 5 is in one of those cells. I don't know. Anyway, I've got to think about this. 3 and 2 are in this group, along with, well, either 5, 4. That's the minimum this could be, is 2, 3, 4, 5, adding up to 14. Ah, if it's taking a cell from these on the right, that can't be any less than 5. And it is. So, minimum 14 there and a 5 on this side somewhere is 19. It's only going to be one more cell, and that is going to be a 1 because it can't be a 2. So either this is 2, 4, 6 here, and we're picking up a 5 this side, or this is 2, 4, 5 here, and we're picking up a 6 this side. That's what we're doing. We're getting 2, 4, 5, 6 and a 1, a yellow 1 in one of those two cells, not there in the 14 cage. So this yellow cage is getting a 5 or a 6 in this column, in one of those two cells, making a virtual pair with that, stopping that being a 6 and making this 7, 8 or 9. 2, 4, 5 or 6 here, and the whatever the yellow, whatever the yellow 5 or 6 here in one of those two cells, with a yellow 1 in one of these two, symmetrically opposite. That's so strange, but nonetheless it is true, and I've got to use it. So the yellow cells in this box, they won't be like that. They're either like that or the other way up, are 1, 2, 4, 5, 6. So the other cells are 3, 7, 8, 9, including this one, which is 3, 7 or 8. Now, maybe I've got to think about the 23 cage next. So the maximum we can put in there is obviously a 9 and an 8, 17. We need 6 more. We need to add 2 more cells or more. I mean, it could even be that shape at the moment, but we're either going up to those 2 cells or these 2 or both. That's not a 2, by the way. Now, we're certainly not making that shape because we would have a congruence problem, which is just weird, but it is true. Oh, let's think about the 21 cage. That might be more profitable. Oh, that might be much more profitable. Oh, look, that's why this yellow can't be that shape, because how are you going to form the 21 cage? Haha, only by creating a Z pentomino which is touching another one. Because this is not enough to make 21. Yes. So the yellow pentomino is that, hexomino is that shape. And we know what is, well, we sort of know what's sticking out on the right. We definitely know what's sticking out on the left. It's a 1 on the left. It's a 5 or 6 on the right. That's a 2, 4, 5, 6 quad. This is 3, 7 or 8. And these are from 7, 8, 9. Okay. Wow. Right. Now, this is either that or both. If it's those, we're using 1 and 3 and either 6 or 7, 10 or 11 there. We have to add 10 or 11 from these, which could be 7 and 4. Alternatively, we're not using those two, we're just using these 3 and making 21, which could be 7, 6, 8, which also uses a 7 here. And that's all it can be. It can't be 8, 4, 9, because that isn't any of them. It can't be 9, 7, 5, because that isn't any of them. This is always a 7, whichever way that 21 is getting made up. And if that does some Sudoku work for me, I will be skipping in the high hills, folks. 7 there, places 9 in box 2, surprisingly. Now that places 9 here. That may even be the last 9 in the grid. I'm not sure, but it's in the 23 cage. Whooey. Okay, this digit, I don't know, it's hardly constrained at all so far. That can't be a 1. Let's do that. Oh, it doesn't matter that we've got a 7. This was either 136, 7, 4 or 7, 6, 8. One, 3, 6 there, or 6 here. So there's always a 6 in this group. And therefore this is 7 down here, and that's 6. Oh, I could have done that ages ago. 7 there, 8, 7. This is Sudoku that I've been missing. No, missing in every sense. I've got a 3-8 pair at the top, so those are resolved. Oh, I've just been not seeing this. That's embarrassing. That's a 4. Ooh, am I still left with a 5-6 pair? Yes, because they're unresolved up here. Okay, maybe that didn't do everything, but 3-6 pair there, 4-8 pair there. Come on. Come on, keep helping me, puzzle. There's a 5 in one of those 3 cells. Don't know what to do about that. That can't be 7. Oh, we've got a 7 in this box. We've had it for ages. Dingbat. Right. I still don't know if that's 1, 3, 6 and in the cage. Oh, can I tell from the rule, the congruence rule? No. That could be a 3 with a 1 there and a 1, 2, 1 up here. Or that could be an X with a 1 there and a 2 there. I cannot tell from the congruence rule. So irritating. Okay, let's go back to this one. This one is now not allowed to be that shape. And it can't take that cell or that cell. Right. So this either extends that way or that way. Okay. Right, if it was 23 going this way, let's do the maths on this row. 23, 30, 32. These would add to 13. There'd be 3, 4, 6. This would be 8, 9, 1, 5. Let's mark that in. 1, 5, 1, 9, 5, 8 would be what's happening there. And that would be 3, 4, 6 if this goes that way. Alternatively, it's an S-shaped tetromino that way with a 1 or a 2 here. These have to add to 13 or 12. Come on, 13 or 12 without a 9. There seem to be too many possibilities. I can't leave those pencil marks in. Bother. Right, maybe I'm just not spotting triples or something, or using the 14 cage. I haven't thought about doing that much lately. If that's an 8, this has to be a 2-4 pair. If it's a 3, they add up to 11. Are you kidding me? Which can't be 3, 8, 9, 2 or 5, 6 and must be 4, 7. There's always a 4 in this cage now. How did that happen? Don't know. But that is an X-wing on 4s in columns 2 and 3 and places 4 in box 4. A 4 up there takes 4 out of that cell and more importantly out of this one, which becomes an 8, and that looks back and makes this a 3, and now this is a 4, 7 pair. Now do we get a 7 X-wing? No, but in the row we've got 1, 2 and 6 to place. Now that is going to have some impact on this potential sum. It is. Can I spot more cleanly what that impact is? Right, if this was the blue area, these have to add to 13 or 12. without using a 9. Right, to add to 13, they would be either 6, 7, which would break those cells, or 8, 5, which wouldn't, yeah, we've got to place 1 and 2 in this column. Okay, there's the point. So one of them has to go in one of these cells. Right, so if we make that the putative shape, it's got a 9 there, a 1 or a 2 here, another 1 or a 2 here, could be the same, but the remaining digit would need to be a minimum 10. So it's not that shape, it's this shape. We know we're not allowed this congruent shape. So it's that shape. We've done it. We have done it. This is going to let me finish off, and I'm going to be so pleased. Right, this now adds up to 23, plus 7 is 30, plus 2 is 32. These add up to 13. I do want to check that I've got this right. If that was a 5, these would add up to 8, and there's no way to do that without reusing a 5. So that's a 6. These add up to 7, and they are 4 and 3, and that is right. Oh, that's an 8. That's been available for quite some time, which is probably the simpler way to do it, but frankly I'm losing my mind at this point, so any way is the right way. That's a 2, 3, 8 triple. This is a 6 in the corner. I've got 1 and 5 to put in this cage. That was what I was trying to mark in earlier, isn't it? It did turn out to be right. I can do 5 and 3 in purple. Oh, I should do my colours, shouldn't I? That 21 cage became an X. Let's finish off the colours. Yeah, that's right. This is another colour. Green for a 2, orange for a 1, where possible. This is a 2, so it's green. Now, we're not allowed another 3 touching another 3. And we can't have a 2 because that would be a 2 because we can't have 2 1s together. So this is another 1, 2, 1 situation. I'm not drawing in the black lines anymore, but there we go. That is the galaxy colorage. And now hopefully I will be allowed to finish the numbers. 7, 2, 1. That's 2. Don't know about 3 and 8. That's an 8. Don't know about 7 and 6. I do know about 6 and 3 here. I do know about 6 and 7. I do know about 4 and 7. I do know about 4 and 8. And I do know about 8 and 3. And we... Oh, no. I've got a 5, 6 at the bottom that I haven't done yet. Here we go. 6 and 5. And that is cosmic cages. And that is a cosmic puzzle, Rodney. Absolutely brilliant. I mean, it's so hard. That stuff with the purple, I honestly barely think I was missing a trick with the total of the purple. It was cruel. Great fun though. Thank you for watching on the channel as always, and bye for now.